We are talking about learning target 6 today, which is very similar to learning target 5. We're going to be doing exponential growth in decay equations, but they're going to be specialized equations that use the number e. So you should have seen this before, probably in chemistry or physics or something. But e is, in this case, a number. That's an approximation, right? Just like pi is 3.14, e is 2.718. On the calculator, there is an E button, and I'll show you that in a little bit. But you'll use that if you don't want to use 2.718, if you can use the E button, just like you don't use 3.14 if you can use the pi button, okay? So e to the x is a special exponential function. And so you have this function. If you put in these variables that you get, you have a domain of all real numbers and a range of all real numbers greater than 0. The importance of this is just to see it, because when we get into the logarithms, this is going to be in one of the inverses we look at. So I just want you to see it once, and we'll come back to it later. What we're really going to do is talk about exponential growth and decay today. So we have a new equation. Again, I'll provide the equations, but I will provide you with what all the letters stand for. So n is still the final amount, and n naught is the initial amount. K is a constant. It might be a rate, it might not be, just kind of depends. And T is time. So the rate is still going to be positive if you have growth, and it's still going to be negative if you have decay. All right? So just like yesterday, it's a different type of equation. Then we have more compound interest equations, but in this case, they're compounded continuously. So they're going to say compounded continuously. Just like yesterday, they said compounded quarterly or compounded monthly. All right? Keep in mind that T has to be in years. I'm telling you this again because on the Learning Target 6 worksheet, one of the questions asks for you to do an account where, well, that's not this equation. That's the equation from Learning Target 5. And then one says compounded continuously, which is this equation, but it gives you time in years and months. So you have to convert everything to years. So just be careful. I've got 2 problems, and they'll be done. So Bakersfield, California was founded in 1859 when Colonel Thomas Baker planted 10 acres of alfalfa for travelers. The city's population can be modeled by the equation, and it gives us a nice little equation right here, where T is the number of years since 1950. So pretty much this 1859 has nothing to do with anything, just some background info. So we're going to answer some questions here. So part A, Bakersfield experienced growth or decline in population? Well, we look and figure this out by looking at the rate, or the constant. In this case, that constant is 0.0397, and it's positive. So because of that, we have growth. Okay? On part B, what was Bakersfield's population in 1950? Well, remember, T is the number of years since 1950. So if it is 1950, what is T? 0, because it's no year since 1950. And if we put that into our equation, we get e to the 0, and e to the 0 is just 1, so we end up getting 33,430. You could have also done that by just knowing that in 1950, that would be the initial population. And this number represents the initial population, so that works too. All right? And then finally, in part C, we're actually going to find a projected population. That says in 2010. So 2010 would have been how many years from 1950? That would be our time. So 60 years. So we're going to have to use the calculator to figure this one out. Now, be careful with your calculator. So I'm going to use 0.0397 times 60. All right, and we're going to raise e to that power. Now, the e button is in 2 places. It's above the division symbol, It's also above the natural log button. And I need to multiply that by the initial population. And we get 361,931. Now, we don't want to really put the 0.04 because we're talking about people, so you can round it, and you can round it up or down, but you can't have 0.04 of a person. That gets kind of difficult. Now, be careful on your calculator because what happens is you guys want to type all of this in at the same time, and that's fine. But when you do that, the exponent has to be in parentheses altogether, or if not, it's going to multiply by the wrong things. Okay? Questions about that example? All right. One more then. Parents are saving for their daughter's college education. If they deposit $12,000 in an account bearing 6.4% interest compounded continuously, how much will be in the account when Ann goes to college in 12 years? Well, so as it says compounded continuously, we have A equals P times E to the RT power. We want to know how much Ann is going to have if $12,000 is put into the account with 6.4% interest for 12 years. Not too bad. So 0.064 times 12 oh my goodness, e to that power times 12,000. Looks like there's going to be $25,865.41. That would be nice, huh? So, that's learning target 6. A few more word problems, just using equations with E involved. Will give you all of the equations. It's going to be your responsibility to know when to use them. So if we need to talk about that more later, we can. So learning target 6.